Good evening, and welcome to Story of the Cosmos. Tonight, we are following a small light into the dark, the story of a spacecraft that left home nearly 50 years ago and never turned back. In the vast dark between the planets, past Mars, past the asteroid belt, past even the slow gold light of Jupiter and Saturn, one small machine is still moving. It left Earth so long ago that most of the people who built it have never seen where it is now. Tonight, its signal is crossing the space between us and it, a whisper of radio waves so faint it could not power a single light bulb, traveling for something close to a full day before it reaches home. Nearly 24 hours. That is how far away it is, measured not in miles, but in the time it takes light itself to close the distance. Send a question out into that darkness, and the answer will not come back until well after you have gone to sleep and woken again. Out there, past where sunlight has any real warmth left in it, is Voyager 1, a spacecraft the size of a small car, carrying instruments built with less memory than a single photograph on a phone. It is the most distant object human hands have ever made, still faithfully listening, still faithfully speaking, in a silence so complete that the spacecraft itself has become one of the loneliest travelers in history. This is its story. Not of a dramatic launch or a single triumphant moment, but of a long, quiet journey. 4.5 decades of drifting farther from everything it once knew, carrying with it a message meant to outlast the stars that made it. Before we return to that story, let the silence settle. Out there, it always has. 16 days before Voyager 1 rose from Cape Canaveral, its twin had already left the ground. Voyager 2 launched first, in the third week of August, carrying the same instruments, the same golden record, the same quiet purpose. But Voyager 1 was given a shorter, steeper road. Within a few months, it had caught up to its sister and pulled ahead, which is why the numbering seems, at first, to run backward. It is not the order of departure that gave Voyager 1 its name, but the order of arrival. Neither spacecraft carried enough fuel to visit 4 planets on its own. What made the mission possible was something rarer than any engine: an alignment. Once every 176 years, Jupiter, Saturn, Uranus, and Neptune arrange themselves along a path that lets a single spacecraft swing from one to the next, borrowing a little of each planet's own momentum to reach the following one. Engineers called it the Grand Tour. It had last been possible in the time of Thomas Jefferson, and would not come again until long after everyone building these machines had died. 2 windows to catch a gift the solar system rarely offers. Each spacecraft weighed only about as much as a small car, a modest bundle of cameras, sensors, and antennae, drifting outward on a trajectory chosen with almost no room for error. Voyager 1's route was the faster of the 2, angled to reach Jupiter first, then Saturn, and beyond that, a choice still years away. For now, it simply climbed, gathering speed in silence, following a door in the sky that had been quietly open for a little while, and would soon begin to close. Jupiter grew slowly at first, a pale smudge sharpening night by night, until by early March of 1979, it filled the sky like something that did not belong there, banded in ochre and cream, turning with a weight no planet has any right to carry. On the 5th of March, Voyager 1 made its closest pass, coming within some 280,000 kilometers of those clouds, closer to Jupiter than the Moon is to Earth. It found things no one had been certain were there. A ring, so thin and dark it had gone unnoticed from home, circling the planet like a rumor. 2 small moons, Thebe and Metis, tucked in close to that ring, quietly added to the family. And then Io. Io was expected to be a dead thing, a scarred and ancient moon like so many others. Instead, the images showed color where there should have been none, and against the black of space, a plume rising from the surface itself. It was a volcano, caught mid-eruption, the first ever seen beyond the Earth. Io, it turned out, is squeezed and flexed by Jupiter's enormous pull, kneaded from within until its interior stays molten, restless, alive in its own strange way. And through all of it, Jupiter was doing something else, something invisible in the pictures. Its gravity took hold of the spacecraft as it passed, and did not simply let it go. It flung it onward, faster than any engine on board could ever have managed, borrowing a fraction of the giant planet's own momentum and giving it to Voyager 1 instead. The spacecraft that arrived slow left fast, already bending towards Saturn, already leaving Jupiter behind as one more marker on a road with no end yet in sight. Saturn arrived differently than Jupiter had. Where Jupiter was fire and storm, Saturn opened slowly, ring within ring, pale and layered, the whole system wrapped in a hush that seemed to match the spacecraft's own quiet approach. Voyager 1 reached it in November of 1980, passing near enough to read details no telescope on Earth had ever resolved. It found 5 moons that had never been seen before, small companions hidden in the planet's long shadow, and it found a ring nobody had catalogued, a faint band of ice and dust that earned a letter of its own, tucked outside the bright rings everyone already knew. The planet gave the spacecraft one more push on the way past, a final gift of speed borrowed the same way Jupiter's had been, quietly added to Voyager's momentum without asking anything in return. But the true turning point at Saturn was smaller than a planet. It was a moon. Titan hung in the dark, wrapped in a haze so thick and so orange that Voyager 1 could not see through it at all. No continents, no coastlines, nothing but a smooth, sealed atmosphere built mostly of nitrogen, familiar in its chemistry and utterly foreign in what it hid. Scientists on Earth had waited years to know what lay beneath that haze, and the answer Voyager sent back was simply more haze, patient and complete. To look at Titan closely, Voyager 1 had to give something up. The path that brought it near enough to study that hidden moon bent it sharply away from the flat plane where the other planets circle. A single deliberate choice that traded away any future glimpse of Uranus or Neptune. There would be no more planets after this one. But there was no hesitation in the decision, no sense of loss in the data. The spacecraft simply turned, following the pull of gravity one last time, and in doing so, quietly set itself on a heading that would carry it away from the planets altogether, out past everything familiar, into the long, empty road toward the stars. Both Voyager spacecraft carried something with them for that road, something that had nothing to do with navigation or power or gravity. Bolted to each one was a golden record, a 12-inch disc of gold-plated copper, assembled by a committee led by the astronomer Carl Sagan. It was, in a sense, a letter, though no one knew if it would ever be opened. On it were sounds gathered from a single, ordinary planet. Surf breaking on a shore, wind moving through grass, thunder, the calls of birds, and the long, low songs of humpback whales, recorded off Bermuda 7 years before launch. There were 115 images encoded in its grooves, and greetings spoken in 55 languages, one voice after another, saying hello in ways that would mean nothing to whoever or whatever eventually heard them, and everything to the people who made them. The last greeting, in English, came from a 6-year-old boy, Carl Sagan's own son, saying simply that these were the words of the children of a planet called Earth. Alongside it ran 90 minutes of music, pulled from cultures and centuries with no attempt to rank them, gathered instead like an offering. The record's cover held instructions of a kind, etched rather than written. A diagram of hydrogen, the most common element in the universe, offered as a shared unit of time and distance. A map of pulsars, each with its own distinct rhythm, marking where the sun sits among them, in case anyone ever wondered where the message had come from. And on the cover too, a small sample of pure uranium, decaying at a known, unhurried rate. Its half-life is measured in billions of years, so long that it functions as a kind of clock, one that any future hands could read to learn how long the record had been traveling. The record itself was built to last far longer than the spacecraft carrying it, engineered to remain playable in the stillness of interstellar space for perhaps a billion years. No one who made it expected a reply. It was not a summons, not an invitation waiting to be answered. It was simply a gesture, cast outward without conditions, carrying a child's greeting and a whale's song together into a silence so vast that it might never be broken at all. Nearly 13 years after that gesture left Earth, the spacecraft itself turned briefly inward. It was February of 1990, and Voyager 1 had already done what it was sent to do. Every planet on its path had been visited, every gravity assist spent, and by rights, its cameras had no more work left to perform. But Carl Sagan, the same astronomer who had helped choose the sounds and images sealed onto that golden record, had spent years asking NASA for one more image. Not for any scientific return, but for something closer to perspective. And so, from about 6 billion kilometers away, farther than any camera had ever looked back from, Voyager 1 turned its lens toward the inner solar system and found Earth. What came home was a photograph in which our entire world appears as less than a single pixel. A mote suspended in a narrow band of scattered sunlight, so small that without knowing exactly where to look, it would be easy to mistake it for nothing at all. Every person who had ever lived, every mountain and ocean and quiet argument and grand ambition, contained within that one pale point of light. Then, just 34 minutes after the shutter closed, Voyager 1's cameras were switched off, permanently. There was no ceremony. It simply stopped seeing, its imaging system left to complete a job it had already finished. It would take until the 1st of May, 4 separate passes through the Deep Space Network's antennas, before all the pieces of that final photograph had made their slow way back to Earth. Sagan would later write about what the image meant to him, calling it a mirror held up at the farthest possible distance. "Look again at that dot," he wrote. "That's here. That's home. That's us." A single point of light, seen once, from farther away than home had ever been seen before, and then never looked at again. Long after that photograph was taken, Voyager 1 kept going, falling deeper into a region of space no one had ever measured directly. By the end of 2004, it had reached what scientists call the termination shock, the place where the outward rush of the solar wind, moving faster than sound, suddenly slows and turns turbulent. From there, it drifted through a wide, murky border zone for years, still inside the sun's great bubble, but only barely. Then, in August of 2012, without any signal or alarm, it crossed over. About 18 billion kilometers from home, Voyager 1 passed through the heliopause and became the first thing built by human hands to leave the region shaped by our star's wind and enter the space between stars. There was no instrument aboard that could simply announce the moment. The plasma sensor, meant to measure it directly, had gone quiet decades earlier. So instead, scientists pieced the crossing together from clues. A sudden drop in particles that belong to the sun, a rise in cosmic rays wandering in from elsewhere in the galaxy, and a shift the spacecraft's plasma wave instrument could still detect, humming through the surrounding space like a stethoscope pressed against the dark. What they found on the other side surprised them. The space beyond the heliopause was not empty, and it was not calm. It was roughly 40 times denser than the thin plasma inside the bubble, and its magnetic field pointed in a direction unlike anything nearby spacecraft had measured, stronger than models predicted, as if the boundary itself were more folded and uneven than anyone had imagined from a distance. And still, crossing that threshold was not the same as leaving. Voyager 1 had passed beyond the sun's wind, but not beyond its pull. Out past the planets, past even the heliopause, the sun's gravity still reaches, holding a vast, slow shell of icy debris called the Oort cloud, which Voyager 1 will not even reach the inner edge of for another 300 years, and will take some 30,000 years more to finally cross. A threshold had been passed. A journey, in the truest sense, had only just begun. The spacecraft's power has always been finite, in a way the emptiness around it is not. Since 1977, 3 plutonium generators aboard Voyager 1 have been quietly decaying, and with them, the electricity available to keep its instruments alive, falling from 470 watts at launch to barely half that now, losing a few watts more with every passing year. There was never a single failure waiting to end the mission. Only this slow arithmetic of diminishing current, and a team on Earth choosing, instrument by instrument, what to let go of first. So the shutdowns have come gently and on purpose. A cosmic ray detector switched off. A charged particle sensor switched off the following year. What remains are just 2 instruments still listening. A magnetometer, feeling for the shape of the magnetic field around it, and a plasma wave sensor tuned to the faint hiss of the interstellar medium, kept alive by careful rationing rather than repair. Even the spacecraft's aging thrusters were coaxed back into service nearly a decade ago, engineers digging through decades-old records and long-forgotten programming languages to fire them again after nearly 40 years of silence, buying the antenna a little more time to stay pointed home. For 50 years, one man watched over all of it. Ed Stone became Voyager's project scientist before either spacecraft left the ground, and he stayed through Jupiter, Saturn, the Golden Record, the pale blue dot, the crossing into interstellar space. A single, patient stewardship spanning nearly the whole of the mission's life. He died in 2024, in his late 80s, with Voyager 1 still faintly transmitting, its ending not yet written. The spacecraft carries on without him now, dimming by degrees, in no hurry to finish what he started. The power is nearly spent now, rationed watt by watt to the 2 instruments still listening. Sometime around 2030, the last of that power will fail too, and the final, readable signal will arrive at Earth after more than a day's crossing of empty space. And then there will be nothing more to send. No last words, no dramatic end. Just silence, arriving on schedule. Voyager 1 will not stop moving. It will keep crossing the dark at the same steady 17 kilometers every second it has held since it last felt the pull of Saturn, carrying its golden record and its whale song, and its greeting from a 6-year-old boy, unheard, unopened, patient. It will spend hundreds of years reaching the inner edge of the Oort cloud, and tens of thousands more passing through it. And somewhere near 40,000 years from now, long after every voice that ever spoke of it has gone quiet, it will drift within less than 2 light years of a small red star called Gliese 445, closer by then to a star it was never meant to visit than to the sun that once sent it on its way. It will not arrive anywhere. It will simply keep going, unhurried, into the dark.